Welcome to DevOps UK. I used to live like 20 minutes walk up the road from here for 20 years, but this is still my first ever DevOps. I kind of left before DevOps UK happened. But welcome. Let's talk about Jenkins X. Before I start talking about Jenkins X, I just want to step back a little bit and talk about what's happening in the software world. So I'm kind of quite old, and I've been doing software for quite a long time. But it feels like the last 5 years, more things have changed about how we compile, build, develop, deploy, test, release, manage software. All of that feels like it's completely changed in the last 5 years. Like the last 5 years feels like more has happened than the last kind of decade or two before it. Yeah, the internet was kind of big, but all of this stuff that's going on right now seems to have changed it for a software developer. So the public cloud's been around for kind of a while now, but the last kind of 5 years we've seen massive uptake in the public cloud, right? 5 years ago we all thought it was a bit of a toy or a thing startups did. Now pretty much every business you talk to, they're all looking to move to the public cloud or move as much as they can to the public cloud as soon as possible. So the public cloud is a big deal. Another big deal has been the move to containers. Like 5 years ago, Docker didn't exist. Containers have been around for a very long time, but 5 years ago, Docker kind of popularized containers, so bless you, thank you, Docker. And now we've all kind of realized that containers are better than virtual machines. So virtual machines are okay, but if you've got any, you should try and move them to containers. Why? A container is smaller, it takes up less memory, less CPU, and less disk. The smaller the amount of memory you use, the less CPU you use, the cheaper your hardware bills and your cloud bill is going to be, right? So just moving from a VM to a container, if you're using a cloud, it will save you money, right? So it's usually about 20%, they reckon, is the average change. So there's a big move to take all those clunky, crusty VMs that we've been using for a while and turn them into containers, which is cool. So why is a container so small? Well, imagine I'm sandwiched between two Spring talks, so let's talk about Spring a lot. So imagine you're building Spring Boot apps. Imagine you're running 3 Spring Boot apps on a cluster. Now, with VMs, you have 3 copies of Linux with 3 device driver stacks and 3 thread schedulers and I/O things and network stacks. That's quite a lot of processes to run. With containers, you're literally running 3 Java processes, and that's it. All a container is some kind of ninja Linux magic using C groups and namespaces and all kinds of crazy stuff like that basically runs 3 processes but isolates them from each other, right? So running containers is literally just running processes, but they're isolated. So you can densely pack containers together. If ever you've tried to run 2 Tomcats on your laptop, one will work and the second one will barf and it will say port 8080 in use. With containers, each container gets its own IP stack so that you can run 20 Tomcats on one machine because each one thinks it's on port 8080, but it's not really. It gets its own kind of ports. So containers are a big deal. We all should use them for pretty much everything. The next problem then is if you move all of your stuff over to containers, how do you run these containers? Like how do you manage them? How do you start them and stop them? How do you keep the containers running? How do you scale them up and down? How do you do load balancing across the containers? Like how do you make it like a containery cloud thingy, right? And this is where something called Kubernetes comes in. I don't know if you've looked at Kubernetes much or tried it. Basically, Kubernetes is completely awesome, so please have a look at it. It's my favorite open source project ever, I think. I wish I'd thought of it, really. It's just an amazing open source project. It's amazing. Now, basically, so Google's been using containers at scale for over a decade. So everything you use at Google, whether it's Gmail, Google Search, obviously, Google Maps, Google Apps, all the Google stuff is all running in containers. So as you can imagine, Google runs lots and lots and lots of containers at scale across all of their data centers, right? Even VMs running containers on Google, which is kind of wacky. So everything's in a container at Google. Not many of us know how to do containers, so Google, bless them, open sourced this thing called Kubernetes about 4 years ago, based on Google's idea of how to do containers right at scale. So Kubernetes kind of came out of the blocks, very much based on something called Omega, based on the internal Google stuff. So Kubernetes is kind of like letting us all run containers like Google, right? It turns us all into Google kind of ninjas. So what Kubernetes does is you can install Kubernetes on your laptop, on any machines you have under the cupboard, in your data center, on the public cloud, and Kubernetes acts as a kind of cloud operating system. It turns a whole rack of machines into a mainframe. I mean that in a nice way, in a kind of mainframe, right? That you can just submit jobs, ask Kubernetes to run some containers, and it runs them for you. It doesn't just run them, it keeps them running. It monitors every container that's running, and if any one of them dies, it restarts it. You can add and remove nodes whenever you want. If you're using a cloud, you can just scale up or down your Kubernetes cluster whenever you feel like. You can scale up or down the number of containers you want to run, and Kubernetes does all the magic for you, right? It's really, really simple. I don't know if you have any operations folks in your company who like tail logs to see if things are still running. On Kubernetes, you don't need to do that stuff, right? Kubernetes uses liveness checks to check all the containers are running and keeps your stuff up and alive. There's a whole raft of, I could talk all day about Kubernetes really, but there's a whole raft of stuff in there. It does things like rolling upgrades, so you can roll forwards and roll backwards your releases. It can do load balancing across your containers. It can attach public persistent volumes to your containers, so you can store state. So Kubernetes is not just for stateless stuff. You can put databases on there, Kafka, Cassandra, Postgres, all that kind of stuff. So Kubernetes is a really big thing. So the cloud is happening. We all want to go to the public cloud. VMs are seen as suboptimal and expensive now, and you should be using containers, and Kubernetes is the new hotness. There's another thing that's happening, though, is how do we build software? I think for years, the software industry, we've been a little bit crap, and we've not really been very good at delivering business value properly, right? We've often spent lots of money, wrote loads of code, but it's maybe not very valuable to the business, right? It's very easy to write the wrong code that doesn't really solve the business problem. And so what we've been trying to do is figure out how, as an industry, should we build software so that it makes value, right? And we do the right thing. So one of those trends, you've probably heard about this already, is microservices. Take those big, monolithic, huge, complex beasts of software and turn them into lots of simple, small microservices. Now, why is that a big deal? Well, it's kind of two things. You split your software into small pieces. Then if you have lots of small pieces, you can have one team that just understands that piece, understands all of the piece. That one team can then edit that code because they understand it all, and they can release that code independently. If you've ever if you've ever read that old book, The Mythical Man Month, whenever you've got a team and you want it to go faster, adding people to it slows it down, right? So you can't just keep adding more and more people to a big monolith. The way you fix that is microservices. You split your monolith into 20 microservices. Each one can go really fast because it's a small team. You don't have those gazillion meetings to decide, can we release the monolith today? And you have to schedule releases and all that kind of horribleness. So microservices are a really nice way of going faster. Another part of the problem, though, is not just splitting things into small things and releasing independently. We want to do something called continuous delivery, where we want to take our software, compile it, build it, put it through staging, put it through testing, get it into production, and get it in front of users as quick as possible, and then get feedback. So we get that feedback loop going. The quicker we can go from code to production and get feedback from real users, real business users, so we can get feedback to see, did that change help? Oh no, it was crap. Let's do something different. Let's try another approach. So that iterative loop is really, really important to delivering business value quickly. It's really hard to know up front what is the right software to build that your users are going to like. Right? So you need to do that iteration to have any clue. We've probably all been involved in software projects that spend years and years in an ivory tower polishing some amazing software, and it goes out the door and the users go, meh. So the only real way of doing this right is just keep iterating, right? The first version of your software should be a little bit crappy, and then just keep iterating and trying to improve all the time, okay? So the whole landscape of building software has changed in the last 5 years. So if we're all trying to be high-performing teams, we've got all these problems to face, which is a worry. So we have to figure out, how do we set up a Kubernetes cluster? How do we split the cluster up into logical environments like testing and staging and production? Then for each of our apps, how do we figure out, how do we turn each of our apps into a Docker image, package it and publish it to a Docker registry? Then we need to figure out, how do we do the Kubernetes YAML stuff, which is the config file you need to use with Kubernetes to deploy things. So we need to figure out all that YAML stuff. Then we need to learn, maybe we should be using this Helm thing, which is the new hotness in Kubernetes for packaging your apps. Helm's kind of like think of a package manager, think of a good package manager that you like. Maybe NPM, maybe Brew, maybe Yum. There's all these different package managers in the software business. Helm is one of the good ones, that it's a package manager for apps on Kubernetes. Well, we'll talk more about Helm in a minute. So we need to figure out the container stuff, the YAML stuff. Then we need to figure out, how do we do continuous delivery? How do we promote stuff? How do we go from my laptop to testing to staging to production? How does that work? There's a new buzzword called GitOps, which is kind of pretty cool and trendy these days. The Weaveworks folks made this up, I think, this year. I think lots of us kind of do this for real in real world, but we've never given it a name before. So GitOps is where we're doing operations, and we put all of the operation configuration, like what clusters do you need, what's your environment configuration, we put that in a Git repository so that everything's versioned in Git. So if ever somebody changes something in production, they change it in Git, in source control, right? As software developers, we know source control is awesome, right? We all use source control, right? Yes. Yes, I hope so. So that somebody changes the source code, you know who changed what when, so if something breaks, you go, it's that commit there, let's revert, right? Do the same for your operations. Put all of your operation configuration, all of your clusters and VM and persistence and all that kind of operational crap, put that in Git and version it. Then everything's versioned and you've got an audit log. If all of a sudden production fails miserably on Tuesday morning, you can see, well, what was the last commit? Should we maybe try revert that one and see if that helps? So it gives you that kind of safety blanket of source control. So GitOps is very cool. So now we need to figure out, we need to put GitOps in there as well. So we need to do the Kubernetes thing, the YAML thing, the Docker thing, the GitOps thing, the environment thing, the promote thing. And then we need to actually deliver some business value for our customers as well while we're doing all of this. So it's a bit of a worry. But don't worry, you have a naval-themed butler in your back pocket who can help you solve all of these problems, right? So you've maybe heard of Jenkins, that Jenkins does kind of CI. The idea of Jenkins X is to deal with this problem of CI and CD on Kubernetes, right? And try automate all of those things that were a worry, so you can just worry about your actual app and writing your source code, right? So that's the idea of Jenkins X. So what does Jenkins X give you? So Jenkins X automates the installation of a whole bunch of open source tools to help you do CI and CD. If you've ever looked at the Kubernetes ecosystem, there's a new tool coming out every day that does a new cool, funky thing. It's really challenging keeping on top of what other stuff in addition to Kubernetes should you use. There's things like Draft and Helm and Scaffold and Prometheus, and there's a gazillion open source projects out there that are all amazing. One of the challenges is which are the ones you should pick and how should you package them together and how should you install it all. So Jenkins X packages up all the best of breed open source stuff, rather like Jenkins has always done in the CI world. It glues all of the open source awesome into a little box and installs it for you. So you just install Jenkins X, it does the rest. You don't have to mess with Nexus and Jenkins and get them to talk to each other or any of that kind of rubbish. So it installs all of your tools, which is cool. That's quite cool. The other thing is it automates your CI and CD pipelines. So in other words, you just create apps or import your apps, and Jenkins X sets up your CI and CD pipelines, so you don't even need to know what a Docker file is, how Jenkins pipelines work under the covers, what Helm even is, right? You can just write your app and deploy it on Kubernetes with CI and CD, with promotion, and with GitOps, right? So the idea we're trying to do with Jenkins X is very different to Jenkins. In fact, if you know Jenkins at all, forget Jenkins for now and just think Jenkins X, it's a very different thing. What we're trying to do is a top-down thing, so CI and CD is just an appliance. It's like a cloud thing. Your developers just use Jenkins X, and it does the CI and CD, and you just develop your app and win, right? So that's the idea. So the other thing it does is it does the GitOps, it does the promotion, and it gives you lots of feedback. One of the challenges, as you start to become more microservice-ish, and you have lots and lots of repos and lots of releases happening all the time, and then you have lots of environments that things are moving between, it can get kind of overwhelming. There's all these stuff and complexity. And so Jenkins X also tries to give you feedback so you know what's actually happening as you move to this new cloud fast world. So that's what Jenkins X tries to do for you. How do we get started with Jenkins X? I'm going to try a live demo of a conference Wi-Fi soon. So I'd rather you didn't try install Jenkins X right now. Like in about half an hour, please fill your boots. But just for now, I don't actually want you to do what's on this slide. So the first thing you need to do is download a little binary called JX. JX is the command line for Jenkins X. It's a little binary. It's not very big. It's quite harmless. You can use Brew if you've got a Mac. You can use curl if you're a Linux person. If you're a Windows person or any other kind of people, just go to the website and download the binary and pop it in your path. So it's a little binary for pretty much all operating systems. And you're going to need JX if you're going to use Jenkins X. So once you've got the binary, you then need to create a cluster. So you need to create a Kubernetes cluster, and then you need to put Jenkins X on it. So we have one command to type, JX create cluster, and the next argument tells you what kind of cluster do you want to make. Like, do you want to use Amazon? JX create cluster, AWS creates an Amazon cluster. It creates an Amazon Kubernetes cluster and installs Jenkins X on top. under the covers using COPS, which is the current Amazon way of using Kubernetes. Soon, by the end of Q2, there's going to be an EKS at Amazon, which is a managed service for Kubernetes. I didn't mention this before, by the way. Friends don't let friends install Kubernetes, right? I love Kubernetes, it's amazing, but installing it and managing it is like a ninja thing. If you want to be a ninja operator, learn how to do that. If you're a developer, please don't do that. Use a managed cloud provider. So this year, Amazon, Google, and Microsoft, and Alibaba, and DigitalOcean will all have a fully managed Kubernetes service. We're all waiting for Amazon to do their thing in Q2 and then have the EKS thing. But once that's out, all of the big three clouds, you can just open a web page, log in, which on Amazon takes a little while, but on Google's really quick. Log in, and then you just say create cluster, and it creates a cluster. And it doesn't just create it, it manages it, right? So you can have your own managed cluster. You say, I want 3 nodes, 5 nodes, 1,000 nodes, whatever. At any point in time, you can add more nodes, you can add less nodes, you can auto-scale your cluster so it grows based on your workload. It's super, super easy. The managed Kubernetes things, they let you upgrade Kubernetes and upgrade the nodes and whatnot. So it's really super, super simple. So if you're a developer, just outsource that stuff, right? Let the public cloud guys do that. The other thing about the managed services on the public cloud, the Kubernetes piece is effectively free. They're basically saying, we're going to figure out the Kubernetes stuff for you. You just pay for the workloads you put in Kubernetes. So Kubernetes on the public cloud is basically free. It's super simple and easy, so please use it. You can install it locally on-premise if you really, really want, but just be aware it's kind of complicated. So please use the public cloud. If someone's already installed a cluster on-premise for you, like there's a tool called KubeSpray, and there's a tool called KubeADM, and there's a bunch of other things. Some people use Terraform, and there's something from Heptio, and OpenShift from Amazon, from Red Hat. There's a whole bunch of different tools out there for installing on-premise clusters. So if you have to do that and someone's installed a cluster for you, you can type JX install, and that will install Jenkins X on that cluster. But the best ones to do are the top ones, where use the public cloud, one command that will create a cluster and install Jenkins X in it. Question? Yes, good question. So the question was, does this work against Minikube? Yes, if you can get Minikube running. I love Minikube, but lots of people I know who try to use it, they have issues with it. The only issue with Minikube is it's not on the internet, so we can't use webhooks. So the promotion is really, really slow because it's kind of polling in a background way. It does work. If you can run Minikube, you can use Jenkins X with Minikube. Lots of people can't use Minikube. Or if they use Minikube, their laptop freezes and they run out of memory. And yeah, so I prefer you to use the public cloud because it's awesome. Minikube is okay. But yes, it does work with Minikube. It works with Minishift as well if you're an OpenShift kind of person. Okay, good question. Right, here's a very quick demo of installing. I wasn't going to do a live demo of installing just because it's kind of boring. You type a command and wait 2 to 3 minutes and then you have a cluster. But you literally type JX create cluster GKE. This video is ever so slightly sped up. You type JX create cluster GKE. It creates a Kubernetes cluster on Google using Google Cloud CLI. It then installs Jenkins X. And the very last thing, and then it finds out a DNS name so it can talk into the cluster so we can use the console and things like that. And then the very last thing is it creates 2 Git repositories. I'll come onto those Git repositories later. But we need 2 Git repositories for doing the GitOps stuff. Good question?
And did you mention Azure as well?
Yes, it works on Azure. Sorry, I should have made that more clear. AKS is the name of the Azure Managed Kubernetes Service. So if you type JX create cluster AKS, that uses Azure. GKE uses Google. AWS uses Amazon. And we're hoping to add, DigitalOcean and Alibaba and Oracle Cloud and Pivotal, and we want to support every Kubernetes cluster. Yes, good question. Okay, so that finished. So we've installed. Usually on Google, this takes like 2 or 3 minutes. It takes a few more minutes on different clouds. Different clouds boot up Kubernetes in different times. But on the public cloud, it should be 10 to 15 minutes. You should be all set up and going. Okay, so that's cool. So what does that give you? Typing JX create cluster. Something. What does that give you? So each team gets their own development environment. So that's a place where each team has their own Jenkins master. So if you want to use the Jenkins console, and whenever you look at it, you just see your team's builds, right? You don't, and pipelines. You don't open the Jenkins console and see every build from everyone in your organization, and you have to kind of squint to see your stuff. Each team also gets an elastic build pod pool, so that as soon as you want to trigger a pipeline, a build triggers immediately on Kubernetes. So you don't have, someone in another department doing 50 builds and you're at the top of the queue and you're sat there kind of waiting. So you have an elastic build queue pool, which is cool. Each team also gets their own staging and production environment. So that means each team can just immediately build apps, roll them out to staging, and then when they're ready, go to production, right? So once you've installed Jenkins X, your developers are primed with all this awesome just to get stuff done and not worry about raising support tickets to ask for things or secretly killing other team members' builds so you can actually get builds done, right? So that's kind of cool. Right, let's do a live demo of a conference Wi-Fi on Google Cloud with GitHub, right? What could possibly go wrong? This is going to be awesome. I can't wait. So let's go to a terminal. And I've installed JX, and I've spun up a Google cluster, on GKE, Google's Container Service, which is my favorite one, by the way. It's awesome. It's really, really awesome. I'm hoping EKS from Amazon is as awesome because it's so easy to use. It's really, really lovely. I love it. So I'm going to type, and AKS is good too. AKS is awesome. So let's just check the internet's working. JX get env. Oh, it's working. Awesome. So what JX get env does is it returns the environments that I have, right? Out of the box, you have a development environment where your developer tools run. You have a staging environment, and you have a production environment. Now, you can add as many environments as you wish. I think pretty much every developer I've ever talked to has an idea in the head of environments, right? We talk about going to production or prod. You might use the term live. You might have an environment called staging. You might call it pre-prod or UAT or something. We all have this idea of environments that software moves through. You can create as many environments as you wish in each team, and you can call them whenever you want, use whatever words you like. It really doesn't matter. Each environment maps under the covers to a Kubernetes namespace, which is a Kubernetes way of segmenting apps from each other. So if you deploy an app into the staging environment, that app can only see the staging database. If you deploy an app to production, it can only see the production database. So you don't have all these magic dollar squigglies or strings that accidentally your staging environment talks to production and everything goes bad. Question?
Does it install a network plugin to enforce the... Because by default you can see...
Good question. Yeah. The question was, does it include a network plugin to protect namespaces from each other at the network level? No. We assume your Kubernetes admin guy is going to fix that. Yeah. So we're kind of defaulting to Kubernetes for everything, and we're just adding stuff on top. Yeah, another question?
In an organization, does every team have to install its own Jenkins X?
Good question. Does every team need to install its own Jenkins X? Today, yes. I work at a company called Carbies, and we're writing a tool to help you manage Jenkins X across large teams. So we're building tooling that you can manage 1,000 teams, and it will do all of that kind of stuff under the covers. We are working as well to reduce the footprint of each team so that your cloud bills are quite small. So you could have 1,000 teams, and you can expense it on your credit card rather than worrying about your cloud bills. So yes. Right, so we've got 4 environments. What was I going to say about, the other thing, promotion. Out of the box, we've decided, as a default, every time you do a release, that release is promoted to the staging environment. But by default, we don't automatically promote to production. So in other words, each environment you can define, does it promote automatically or is it manually? And you can change this however you want, right? What we kind of want you all to do is turn on automatic promotion and go straight to production automatically whenever you do a release. It's kind of what we're all aiming towards full automation. But initially, I can imagine lots of people being slightly scared that every time they merge to master, a release goes out and it goes straight to production. So we've currently got this manual promotion step. So you choose when something goes from staging to production. And at any point in time, you can revert it back again, right? So that step is currently manual, but it's up to you if you want to keep it real, you can just go straight to production automatically, right? It's up to you. You can see, well, maybe in one of those columns, the 4th column in, it's the promotion strategy. So staging is auto and production is manual. You can just edit those using the JX command line if you like. And create as many environments as you like. You might want to create a system testing environment, a load testing environment. Have as many environments as you wish. It's all fine. Right. Let's use Jenkins X, and let's do some Spring Boot. I know Josh is next, so Spring Boot is awesome. So let's do some Spring Boot. So we have a command, JX create Spring. I think you can see that. JX create Spring under the covers is using the start.spring.io. If you're a Spring person, you probably know all this already. The Spring initializer thingy, which is a wizard that lets you spin up new projects. So it asks, What programming language do we wish to use? We'll go with Java for now. What group ID in the Maven POM thingy? I'll just hit return. What am I going to call this? Devox Rocks. That's a really cheesy name, but let's go with it. Now it's asking me what Spring Boot dependencies do we want to put in here. So this is all the Spring Boot optional modules. So we'll say, yeah, we'll use the actuator, and let's use the web thingy too, and hit return. So we've created the project now on my local hard drive. Do I want to use my GitHub name? Yes. Would I like to initialize Git? Yes, please. We want a Git repository. So here's all the files it's generated. So far, those files are all just start.spring.io stuff, right? We haven't touched it or modified it. We're delegating to start.spring.io for all that stuff. Commit message, that looks fine to me. I'll just hit return. Now something called a build pack is going to run. And a build pack is this thing that's going to look at all the source code, figure out how to turn it into a Docker image. Hi, Josh, by the way. Figure out how to turn it into a Docker image, figure out how to run it on Kubernetes using a Helm chart, and figure out the ideal pipeline to deploy it. So now it's going to create a GitHub repository for my source code. So I'm going to use my username, and that looks good to me. And I'm going to cross my fingers that GitHub stays up for the next 10 minutes. It's looking good. It's looking good. Awesome. It worked. Yay. Go internet. So I'm just going to show you that I'm not cheating. I'm going to click on that URL. So this is the GitHub repository we've just created. So this is just your regular GitHub repository. So what I basically did there, created a new Spring Boot app, ran the Jenkins X build pack to add a few extra bits and pieces in there, and then uploaded it into GitHub. So you'll see, for example, we've added a Docker file, which is the file that takes the Spring Boot application and packages it as a Docker image. So Docker files are the industry standard way of making containers. There's something called a scaffold YAML. Don't worry too much about that, but that scaffold is a cool new Google project that lets you build Docker images using different technologies. So one of them uses the local Docker daemon. This is totally geek stuff, and you don't need to worry about this if you're a developer, but you can use the local Docker daemon. You can use the Google Container Builder service, which is like a remote Docker building thingy. Or you can use another open source project called Canico with a K, which does Docker builds without the Docker socket. Don't worry about that for now. So that basic scaffold is our abstraction for building Docker images. Then there's a Jenkins file there as well, by the way, which is the thing that we use to define the CI and CD pipelines in Jenkins. So we've created the project, everything's gone to Git, that all sounds cool, and then if I just type this command here, I'm just going to copy and paste that and hit return. Oh, it's even building, that's awesome. So what's happened is we've created the project and we've pushed to the master branch. And whenever we push to the master branch, Jenkins X triggers a release pipeline, which is going to do a release of this project. So it's going to tag the source control, tag the branch with a new version number. It's going to create a version number first. So it's going to create 001 by default. Then the next release will be 002, and it goes up incrementally. If you ever want to do a big jump to, say, 1.0 or 2.0, you can edit the POM XML in Java, or you can edit the package.json in Node, or you can just do a git tag to tag it. All the versions are managed with git tags, so it automatically keeps track of what the version number is using git, which is nice. So it's going to tag the source code. It's going to change all the POMs to say the version number is 001, commit that in as a branch, tag it. It's then going to build the jar, release the jar with 001 and the POM XML and all that kind of stuff. Then it's going to build a Docker image, tag that with 001. Then it's going to make a Helm chart, release that into the chart repository. Then it's going to do the promotion. Okay? This is going to take a moment or two. I think the release is probably finished by now. Yeah, I think it does. So if I go back to the project and click on the release tab, see that there's a release now. So we've just made a release. Because we pushed the master, it's made a release, it's tagged it. So you don't have to sit there and scratch your head and figure out how do we do version naming again, and how do we do tagging, and how do we do all of that kind of stuff. It's created the release. It's also created the change log automatically, which lists all of the issues you've fixed, all of the stuff that's happened in that release. So as you start going faster and faster, you can start to see what did happen in 001 and what did happen in 002, and let's do a diff between them and stuff. So it's done the release. Now it's doing the promotion. So it promotes to all of the environments in turn that are defined as automatic, which in this case is staging. And see this URL here, we've created a pull request. So let me describe what this is. So this is the pull request. So with GitOps, to do a promotion to the staging environment, what we do is we do a pull request. We request a change in the source code for that environment. So each environment has a Git repository with all of the configuration in there. So to promote, what we've done is we've generated a pull request. And if I look at the diff of that, we'll see, don't worry about the details of this. This is totally implementation details. But we basically add 3 lines to this YAML file that says, what's the name of the app, where's the chart repository the app lives in, and what's the version of the app, right? What that pull request then does is trigger a pipeline on the environment that then validates, is this Helm chart valid? Can it find the Docker image? Did you mess anything up? Is everything working all right? And if that passes, you get a green. Any minute now, that should hopefully go green. Hey, it worked. So we've just merged. So if I click reload, there we go. So it triggered the CI pipeline to validate the pull request is valid. It was, so then it's merged. Now it's merged, so now it's going to trigger another pipeline that says whenever you push to the master branch of the environment, trigger a new build, which is going to use Helm to apply the new config. Now this might seem slightly extra complex, but the beautiful thing is any change to the environment configuration goes through this same pull request loop. So we get CI running on the environment before you make any change, and then only things which are approved are merged into the master branch, and then they get released. So the merge should finish fairly soon. So we have merged, so the release pipeline should hopefully finish in a moment or two, and then we'll have our app actually running in the staging environment. Okay. So just to recap what we did, we typed one command, jx create Spring. It's created a Spring Boot app using start.spring.io. It's then automated the pipeline for CI and CD, and it's released the app. So the idea is whenever you create an app or you import an app, you release it to staging and promote it to staging immediately. Then developers can iteratively edit the app, and every time you make a change, it gets released. So you get developers used to going through this develop-release cycle, right? You don't want to sit there for 3 months hacking some code and then realize it doesn't even run in Kubernetes, right? You want to always be deploying things in Kubernetes so you know it works, you know it's valid, and you can go quickly. And it's just about finished. Oh, it's finished. Awesome. So see this link at the bottom? That's now a link to the running app in the staging environment. So if I click on it, hopefully the JVM's, yeah, the JVM's up. Awesome. So this is the default homepage in a default Spring Boot app, right? So that it might look like it's not working correctly. Those people who know Spring Boot know this is working correctly, right? That's the normal page for a Spring Boot app when you haven't written any code yet, right? Right, so that's kind of okay. So let's do something a bit more interesting now. Let's do a pull request and show you how pull requests work. So let's do a very quick coding demo. I've just about got time. So if I go into DevOps Rocks, so here's the source code of my file system. And there's the Git repository and all that kind of stuff. So I'm going to use the command line for all this. So you can see there's no magic, there's no weird shell scripts or anything. I'm going to use just Git. So I'm going to use Git checkout, Git branch cheese, Git checkout cheese. So I'm going to make a code change. I'm going to cheat slightly. I have a file I made earlier. So there we go. I'm going to do git add source, git status. So we've added a new file. And now I'm going to do a git commit. I always forget the A usually on the git commit. Fix, add, more, awesome. Cool. Then I'm going to do a git push. And GitHub's working, brilliant, that's awesome. I love GitHub. And then if I go back to the project, no, that one. If I go back to the project, we'll see, yay, GitHub is saying, oh, do you want to do a pull request? So we say, oh, yes, please. Thank you, Mr. GitHub. So we click the button and click a pull request. So we've created a pull request. Notice the CI pipeline should trigger soonish. Any soonish? You can see in this window, by the way, it's already chugging along. GitHub hasn't refreshed yet. Anyway, now GitHub should refresh to show that, yeah, there we go. So GitHub is saying, yes, there's a CI pipeline running because we've submitted a pull request. So what's happening now is Jenkins X is automating a pull request pipeline. And that pull request pipeline is going to take those code changes we just made, compile it, run all the tests, check it's valid, whatever checks you have in your POM and whatever. So it's going to check your code. And then only if your code passes, your test passes and your code works, are you able to merge this change. So that's good. Jenkins X also does something else as well by default. You can opt out of this, but something else it does. We have something called preview environments. And what that means is every time you submit a pull request, we'll run your test, compile your code, check everything's valid. We'll then create a temporary environment for the pull request. We'll then deploy your app in Kubernetes into a separate namespace for this pull request to check your app and your pull request runs, to check it actually starts up and runs in Kubernetes, right? Then what we do is we comment on the pull request with a link to where the app's running for the pull request. Now, we do all of this before we merge, right? Now, this is an important point. What we kind of want to do is move as much of the testing and validating and approval of changes into the pull request so that you're keeping master, the master branch, clean at all times, and you only change master when you're happy with a change, right? A lot of things we do in software is a little bit experimental, like an issue is raised to, I don't know, redesign the homepage. So you have a go at redesigning it. You kind of want someone to look at it and go, is this what you meant? And they go yes or no. And if it's a no, you just close the pull request and forget all about it and you try again. If you're building any kind of UI, we found preview environments super useful because it lets people preview the change before you've merged it to master to avoid all of that git revert kind of horribleness and all that kind of stuff. So you can approve changes before you merge to master. So hopefully soonish, this pipeline should finish. Hopefully. I've probably just got time to wait for it to finish. So the pipeline is chugging along, it's building, what we actually do under the covers is we create a new Docker image with a pull request name in it as its version, and the build number as its version. We push that into a Docker registry, then we create a Helm chart for the preview environment, and then deploy that into a custom namespace. Nearly there. Oh, I think it's finished. Yay, awesome. So notice the UI update of GitHub. It says a pull request was built and available at this preview environment. And you see that link there? If you click on the link, that link takes you to the app that's running in the preview environment with your pull request inside. And we still haven't merged to master yet, right? So we're testing a change on a pull request before it goes to master. So if I click on that, hey, it's even working. Awesome. So here we've got a slightly different homepage now with a bit more awesome. The image might load eventually. There's a really awesome logo that might... Yay, there we go. The internet's a bit slow today. So this is the new homepage. So that pull request, basically, I was adding a new homepage, right? So this is the new homepage. So we can say, yeah, that looks good to me. So let's click merge. Let me reload the browser, because it should be great. It's green, I can merge it, so I'm going to hit merge and merge it. So now I've clicked merge. We should, in a second, see the pipeline chug along again, because now it's going to trigger a release of 002. So 002, because we now merged to master, the master branch has now got this change that we've agreed is good. And then it's going to chug through this whole thing again, release 002. 002 is going to be promoted to staging again, right? So just to recap what we've just seen, in one command I created a Spring Boot application and we released 001. I used normal Git stuff to create a pull request on that repo. We used a preview environment so we can preview the change before we commit and agree to merge it. Then when we merge it to master, another release happens and that change then goes out automatically to staging, which give it a few moments, that will hopefully work. Just a quick note on preview environments. How they work under the covers is everything in your repository, in your Git repository, defines your pipeline, your Docker file, your Helm chart. So everything you need to do to make your app is all in your source tree. So you don't need to know what Docker files are or how they work. You don't need to know what a Jenkins file is or even what a Helm chart is. But if ever you want to tweak anything, it's all just in Git. So you can just edit the pipeline, edit the Docker file on a pull request, submit it. If the pull request passes, merge to master, you're good to go. So if you don't like the out-of-the-box build pack stuff for Docker files or pipelines or Helm charts, you can just edit them on each project, right, which is cool. The other thing that's interesting with preview environments is imagine you're doing a front end and a back end and you've got a database, right? And you're doing a pull request on the front end. When we deploy that front end app, you probably need other stuff it talks to, like it might need a back end or a database or another thing. We define the preview environment using something called Helm, which is from Microsoft and is a lovely, lovely thing. And it uses YAML to define what dependencies does the app need. Like, does it need a database? Does it need a back-end service? So you can define exactly what a preview environment is. A preview environment is up to you to define how much or a little of your system you need. The other thing that's interesting about preview environments is you can, often you might want to use, for example, your staging environment for your back end. So you might want to run the front end, but point it at the staging environment. So you might not want to run all of your microservices in the preview environment. You can do something called service linking to link to, say, the staging environment, or if you're more brave, the production environment. So you could run the new front end against the production environment if you wish. And it's up to you to define on a per repository basis how you want that kind of stuff to work. Another thing people do with preview environments is use it as a way of doing system testing. Because you can define arbitrary other Helm dependencies, which could be Selenium or some kind of load testing tool or whatever. So your preview environment could basically be a system test if you want it to be. It's completely up to you. So preview environments are awesome. So I've got a little bit of time left. I'm going to do a couple more demos. Let me show you how development works. So for this one, I'm going to create a different kind of app. I'm going to show you, now Spring Boot is awesome. You should definitely use Spring Boot. Josh is in the room, so I have to, no, it really is good. I love it. Some people might want to use Node.js, say, which is fine. So let's show you how a Node.js app works. So we do create quick start. Yeah, I'll use Git. And it gives you a list of some quick starts, and we'll pick the Node one. Yeah, cool. And then what name shall I call it? Devoxx Node. I'm not having a good naming day today, but never mind. And this is, notice it's all like JavaScript and stuff now. There's no Java or anything. So we'll create that. And it's basically the same kind of thing. We're creating a new Git repository. It's going to create a CI job and yada, yada, yada. And so hopefully this will then trigger the pipeline. Let's type that in there. So now we're going to build a Node.js app in the same kind of way, right? So these we have build packs for pretty much all the popular languages, Go, Rust, Java, Maven, Gradle, Scala. Pretty much most stuff you're building, we have a build pack for already. If you don't, we can make new build packs really easily, so let us know. Right, now what I'm going to do is something a little bit different. Devoxx, did I call it Devoxx Node? Yeah, I did. Okay, here we go. I'm going to create something called a dev pod. So Dex create dev pod. So dev pods, okay, let me explain this a little bit. Inside it, when we're doing CI and CD pipelines, we use containers in Kubernetes to run the build. So when we're using things like Maven or Docker or Helm to actually make the build and release the build, we're running all of those in containers inside the Kubernetes cluster. So we have these things called pod templates, which are Kubernetes things that defines what are all the Docker containers that have all of the software tools, like what version of Maven do you want to use, what version of Docker, what version of Helm, all that stuff we need to do to CI and CD, right? Now, as a developer, you kind of want to use the same tools, really. One of the things that's wasteful in software is if I've got some random version of Maven on my laptop, and everything's working on my laptop because I've got some random version of Maven, and then as soon as the CI pipeline runs, everything breaks because there's a different version of Maven and everything breaks. So we kind of want to get developers in the habit of using the same stuff all the time. So use the same version of the software tools at development time as your CI and CD pipelines are going to use. So a dev pod is basically that. Hopefully the dev pod starts at some point. I'll keep talking while it's starting. I think I'm a bit low on my quota on my Google Cloud. So hopefully the dev pod starts. So what a dev pod is it's using the exact same containers under the cover. So the exact same Maven, the exact same Git and Docker and all those kind of things. If this ever starts. So what this basically means is it's starting up a new pod with the pods, with the containers for your tools. Then it's going to open a shell into that pod. So what that basically means is you can avoid installing everything on your laptop. You can just make a dev pod, which opens a shell into a container in a Kubernetes cluster, right, if you can follow that. So we run a single container in Kubernetes, and each developer gets their own pod, and then you can log in or SSH in. It's not using SSH, but think of it like that. You log into that pod, and then you can run commands there. So that's kind of cool. Hopefully that might start today, and I'll keep talking until it does. If it does start, we have another tool. So one of the other problems is people like to use their desktop IDEs. So you might like VS Code, or you might like IntelliJ or Eclipse, or all those kind of things. So as developers, we want to kind of develop on our laptop with our IDE of choice or editor of choice, but we kind of want to run everything on the public cloud, right? The more you use the public cloud, the more you're running on something that's almost the same as production. So we all want to be using the public cloud all the time. I hope this finishes one of these days. I'll carry on as if it's working, and we'll see how this goes. So that was DevOps, Node, I'll start up an IDE. I'll use VS Code for this one, just because it starts really quickly, but we can use any IDE. I might come back to this demo in a second. I'll tell you what, let me talk about a few other things, and we'll see if this ever starts up. Everything you've seen right now is all Jenkins X. It's all completely open source. You can download it, do whatever you like with it. It's all awesome. Please try it out and give us feedback and let us know what works, what doesn't work, what you like, what you don't like. I'm just going to show you a very quick thing. I work for a company called CloudBees, and one of the challenges for doing continuous delivery is understanding what the hell is going on. So we have two kind of things at CloudBees as products we're building. One of them is a chatbot, so every time anything happens in the CI or CD thing, we get a nice little chatbot notification with links to, for example, what pull request has just happened in a staging environment with a link to it, so you can just open it. What release has just gone out? What app is now in the staging? What app is now in production? To give you that kind of chat experience so your team can see what's going on. We're also working on a UI. As soon as you start having like 5 pull requests across 10 projects and then release pipelines going at the same time, understanding which version is running where in which environment just becomes insane. And you find yourself, I know you have like 50 browser tabs open. And now and again your browser crashes and you've lost all your tabs and it takes you like an hour to find all the tabs again. So we've got this simple UI we're building. Well, not just simple, it's an awesome UI. We've got this awesome UI we're building that really helps you understand what are all the pull requests that are going on, what are all the staging environments, what's the production environment, what are the apps you have, and then what's been happening in them, what version is live, what version is staging, what version is in production, and what's the activity on your stuff, what pods are running, so what Kubernetes resources are running, which commits have happened, what resources are running, how much CPU you're using, and all that kind of stuff. So it's a nice, simple way of understanding what's going on. When you're doing manual promotion, you can use manual promotion from the command line. There's a command JX promote, and you just give the app name and the environment name and the version, and it does the promotion for you. However, that's kind of error-prone and a bit kind of hardcore, so we're building the promotion logic into the UI, so it's a nice, slick promote button, right? So that's coming soon. Right, hopefully this pod has... Yes, it started! Hooray! Go Google! So the dev pod has started. Brilliant. So basically, you see how my shell's changed a little bit? I'm now in a completely different directory. I do current working directory. So I'm basically, this shell is now running inside a container in Google's cloud, which is kind of wacky. But if I do an ls, there's no code here. So if I go into here and I type another command, jx sync, I'm going to cross my fingers because this doesn't always work. Hopefully, if the demo gods are with me, what this is going to do is it's going to synchronize my local laptop's file system into the pod that's running in Kubernetes, right? Hopefully. Okay, I'm just going to do one more cheat. This is very new code, and it's a little bit fragile, and it sometimes gets a bit confused. So I'm just going to do a quick change. We will fix that bug soon. Okay, this time it should sync. We only built this code like last week. Okay. ls-al. Is there something there? Yes, awesome. So now we've got the source code for this Node.js app running in a container inside Google. And now we can run a command called watch. And what watch is going to do is it's going to build this code locally with the same technology that the CI and CD pipelines are going to do, and then it's deployed the Helm chart into a personal edit environment. Now, if I do a JX get app, oh, this might be quite wide. Let me do it here, actually. JX get app. It shows us all the apps I can see, and one of those apps, this doesn't look good on a wrapping thing. We can see what's in staging and what version, and we can also see we've got an edit app here in my personal edit environment. So if I open that in a browser, hopefully that'll work. Yay! So this is the Node.js app. So we basically built, deployed, and ran a Node.js app in my personal environment, personal namespace, without committing any code. So this is a way of doing development before you do a git commit. And let's see if I've got time to finish this demo. If I go back into here and oh, VS Code's not working. Demo gods are not good today. Devox, what was it called? Devox node. Yeah, okay. Let's try VS Code again. Come on, VS Code, you can do it. Oh, phew. Okay, cool. So if I open a terminal, my time's up. I'm not going to be able to show you this. I'm going to go ever so slightly over. I hope that's okay with everyone. Right, so now what I'm going to do is I'm going to make a live code change. I'm going to say awesome. And what's hopefully going to happen is I've changed some code on my laptop. Let's see if I can show you the terminal updating. I've changed some code on my laptop. What's happened is JXSync has synchronized that into the pod that's running in Kubernetes. Then the pod in Kubernetes has rebuilt the Docker image. And then hopefully you see awesome. Well, that was really bad typing. Did I type it? Oh, no, I typed it right. Cool. It just looks weird from the side. So what I've basically done is I've edited on my desktop laptop, and it's rebuilt and ran in the public cloud within a couple of seconds, right? So before you commit, you can develop locally on your laptop, do all of your building and running in the cloud, and do development fast without running stuff on your laptop. So that was a very quick whirlwind tour of Jenkins X. Let me show you the last slide in case you need any links. I'm here all day today and here tomorrow. So if you've got any questions, come and grab me. Thanks for listening. Please download it and try it out now because my demo's over. So please download it and try it. Thank you very much. Thank you. Cheers.